Welcome to this video tutorial on reinforced concrete continuous beam design to Eurocode 2 using the PROKON software. To begin, we need to launch PROKON version 5.2 from the software hub at the link below. Select version 5.2 on relaunch. Click open, and in a few moments we'll be asked to sign in. The credentials we used here are the ones which are linked to the PROKON licensing server. An email would have been sent from noreply@lima.prokon.com inviting you to create a password for your PROKON account. Please follow the instructions provided in that email and ensure that your password is created or updated before the session. Please also take note of the username format. This may be either your N number at my.ntu.ac.uk or in the format firstname.lastname year at my.ntu.ac.uk. And together with the password created, you'll need these credentials to log into the PROKON during the session. Press Authenticate. A link to the PROKON licensing server will also be provided below. Once the license manager has signed in, we select the license set, which is in this case is structural. We select the option and click OK. Now we have signed in. On the ribbon, we go to the Concrete tab and we select the first option, Continuous Beam. Firstly, as we're designing to Eurocode 2, we need to change the design code. To do that, we go to File, select Design Code. Under Europe, we have the latest Eurocode 2 2023 and select OK. You can see now that the dead load factor and the live load factor are 1.35 and 1.5 accordingly, and the notation is what we're used to. Now we enter the parameters of our concrete beam. The concrete compressive strength, denoted as FCK, will keep as 30. In this example, we use concrete strength of C30-37. For Fy and Fyb, which is the steel strength, we, for in this example, will change our value to 500 megapascals. For the percentage redistribution, we change this to 15% for a continuous beam, as we've seen in the lectures. We can also change the value of the top and bottom cover for reinforcement. In this example, we'll use 30 millimeters for both. And we can save these as default. The next step should be to define our concrete section. To do that, we go to the Sections tab on the ribbon. We enter our section number, in this case, section number 1, and we can change our depth and our width to 500 millimeters for a 500 millimeter square section, and that will be depicted here as so. Thereafter, we move on to the spans. In this example, we will look at a 5-span continuous beam, with each span being 7.5 meters long. To do that, we enter the number of spans which we have, in this case, 5. Each of our spans is 7.5 meters in length. And the section number on the left and right, in this case, is section number 1, as defined earlier. Once we have selected the input for the spans, we move on to the supports. As you can see, for 5 spans, we'll have n+1, which is 6 supports. Three, 4, 5, 6. For CF code, this refers to whether the span is cantilever or fixed. By default, it is fixed. However, if, for example, we had a cantilever span on span 1, if we change this to C, we'll see there's no support on the end of span 1 as it's cantilever, but for this example, we'll leave it as a fixed support. The next data we need to import is the column dimensions above and below. In this case, we'll have a column of 450 by 450 in cross section with a height of 3 meters on either side. And we can also copy and paste these values, and we'll copy the same for the top as well. Now we've entered our supports. The next section we need to move on is loads. We'll have 2 load cases, one for permanent actions and one for variable actions. For permanent actions, we'll name it as D for dead load, and for variable, L for live load. We need to do this for each span. So we'll start off with span 1. And on the left, we'll put the dead load as 50 kilonewton per meter on the right and left, and 10 kilonewton per meter for the live load. We'll duplicate this for all 5 spans. As you can see, PROKON automatically calculates the self-weight. As our input is 50, as you can see, it's being increased to 56. Now we've defined our continuous beam, we can move on to the reinforcement. So if you select reinforcement on the reinforcement tab, we can input our detailing parameters. For our beam type, we only have one type, so we'll go with 1. The maximum bar length, we'll change this for example, to 12 meters, being the maximum length of bar which can be carried on a flat load truck in the UK. For the top minimum and maximum bar diameter, this will refer to the diameter of the hanger bars. We can keep this as 12 millimeters, and the maximum could be 40, but in this case, let's change it to 25. For the bottom, reinforcement. These are the main reinforcement bars. From the lecture, we learned that the minimum can be from about 16 millimeters. We can change this to 16. And maximum, we can leave it as 40, but it's best practice to keep that as 25 also. Our stirrups refer to the shear links. This can be between 8 and 12 millimeters, with the shape code being 60. We can now generate our reinforcement. As you can see, the software has automatically determined different values of reinforcement bars at different locations along our continuous beam. If we go to our stirrups, we can see our shear links. We've got 4 legs using 2 links here. Looking at our shear reinforcement, the spacing has been provided as so. If we look at our cross sections, we can see the cross section at each point. Cross section B, C, D, E, for example, and you can also drag and move it around. So span 3, for example, at mid-span would have a reinforcement layout such as this. We can also go to a 3D view where we can see and we can pan and rotate, see how our reinforcement has been designed along this beam. Thereafter, to output any of our design calculations, we can go to Calc Sheet. This will automatically populate data based on our inputs, as you can see. Then we can print this to Microsoft Print to PDF. Select OK and decide where to print it. That's all for this video. I hope it was useful for your coursework, and thank you very much for watching.